Yesterday we have started with the steam generators, or in very short, the boilers. Let us go through the other portion of this boiler itself. This is other type of fire tube boilers, that is called oil fired pressurized pipe boiler itself. What we have, it is given in the sketch itself. It is internally fixed fire tube boilers. It is fire tube means its whole fire tubes are here. It is somewhere, all these things are fire tubes are here. It is fixed inside the water drum inside. Uh, it, since the furnace is furnace well within the cylindrical shell, means cylindrical shell means it contains this, in a single shell it contains water as well as the tubes for tubes for running the flue gases inside the running flue gases surrounded by the boiler water itself. Now the oil is filtered first. Where is the oil here? Here you see this is a oil tank here, and there is a valve here for opening and closing the oil tank, or supply, to control the supply. It can be fully open, fully closed, or partially open. There is a pump is here, which is supposed to pump the oil up to the furnace itself, and there is a pressure gauge showing here, which shows the pressure of pumping and pressure of pumping the oil to the network itself. Uh, Now, from the pump, from the pressure gauge of the what pressure gauge of this oil tanker, it goes to the oil filter, which will filter all these necessary impurities present in impurities or darts present in the oils, especially when it is because when the oil is coming back to the main oil line after for recirculation, and the slags just created in the oil filter is being removed manually or by some artificial means, so that the clean and purified oil goes to the oil heater itself. Oil heater may have oil heater, oil filter then goes to oil heaters, where you have some burners for heating it, or or burners for heating, and sometimes also it's a coil for electrical coil is there for heating, so that there should not be any flame inside the oil heater, but it is heated and burned. Starts fumes are formed there inside the oil heater itself. Next is goes again through a temperature controller, through a damper, through another passage, and there is a fast driven fan, FD fan, which circulates the air and through the oil tanker itself, which makes an flow of the flue gases resulted from the burnt oil, and it will goes to the furnace itself. Then from the furnace, it is good through the passage. It went inside these particular tubes from here, here, and here, and then it is recirculated again from this tube coming out, and then goes exhausted as the chimney itself. And these tubes are in direct contact with the water for boiling, and is the water for boiling, and the heat exhausted from the tube itself is being transported to the boiler, for which is get heated, and the steam is converted into steam itself. The steam is generally expressed on the higher side of the boiler, and which contains a safety valve, and through which the steam is exhausted, and the safety valve through which exhaust gas, some, if there is any additional pressure is created inside the boiler and steam drum, this will be open and let it exhausted, and to get the pressure up to the limit where it is set. And then steam is supposed to supply from through this valve here, and through this main carburetor line, where it is again reheated by the flue gas itself, flue gas itself, and then it comes out to the main stop valve. Another stop valve is there, then goes to the flame supply itself. So what is the specialty of this step oil drive furnace is it has a separate place for the oil tanker where it can be poured as per the limit. The oil pump is there for flue, and air pump is there for maintaining the oil flow itself. So there are two pumps. One is for pumping, and another is for pumping oil, and another is for pumping air. And oil is burned inside the oil heater by means of a flame or by means of a electrical coil itself, and the flue gases comes through the damper here and comes through the injector here and goes to the furnace itself. And the flue gases thus flows here and, and again reflow here like this, and ultimately goes back to the exhaust chimney. And uh, from the steam thus generated is as it is surrounded this it is surrounded the tubes through which the flue gas is hot flue gas is flowing, which transfers the heat to the water, which converted into steam, and uh, it temperature is reduced, and reduced with reduced temperature is exhaust to the chimney, and the whole whole tubes as well as the whole water drum is inside a single housing, along with a coordinated flue through which the initial flue exhaust moves, because it transfers the heat to the surrounding water to a better form. And then there is a safety valve here. If there is overpressure created, then the safety valve opens and additional steam or water will exhaust to make the pressure inside safe and within limit. And there is a manhole somewhere here, somewhere in the top. It is required to, when at the cool time when this water drum is required to be cleaned, or maintenance is required for the tube, the person consumption come down through this manhole itself. Then it has a safety valve, and first it has a control valve itself, then goes to another coil of steam and vapor, which also has exposed to the flue gas itself, so that it got heated to the superheated temperature, and then goes to the main stop valve, and through which it goes out the steam supply. The pressure of the steam is supposed to be such that it is for comparatively less pressure, the water will convert it into the steam in rather quickly, and it is steam is superheated in this position. When this portion of the coil, when the steam flows through this portion of the coil, this steam is got the superheated itself. Now, what is here? This oil-fired pressure tube boilers is actually the internally fired tube boilers. This is fired tubes here. These are all fired tubes. That it is fired inside the furnace of the inside this whole unit, which houses the steam drum as well as the flue, and as well as the corrugated fire tubes. The oil initially filtered here to make it totally make it slag free, because a portion of the oil is coming back to the situation if the amount required is more than the demand, and that coil is recycled. So somehow or other their recycle is going on, and recycled oil is supposed to be filtered in a better way, because it may require certain fumes, dust inside it. Now, this excess oil return to the main field line itself. The combustion here, what occurs first? Here, this is the burner itself. Okay, this is the heater. Oil is heated to a certain up to a certain temperature. Then it is the burner itself where mm, then it is a burner itself which burns the oil and let it flow by by means of this pressure of the FD fan through the corrugated horizontal corrugated flue. It is called horizontal corrugated flue itself because uh, and the combustion gas flow through the tubes in two passes until till they are let out through the chimney to the atmosphere itself. So first we are the flue gases passes through tubes. Next is passes surrounding this tube itself, surrounding this tube, uh, surrounding the water tubes, water stream tubes. When it is coming up, it is first of all It is coming inside the tube here, and it is coming out here, and surrounded this portion of the tubes which carries steam, then again goes through this portion inside the tube and comes out and goes out to exhaust the chimney itself. The corrugation of this tube cause strength, increase the strength and help in allowing thermal and extraction and contraction also in cracking and removal of the soil shoots deposited. Here, this corrugated beam, if it is a plane, the shoots may take a rigid formation over its top, but as it is corrugated, the shoots may break here, may easily break here, and can be cleaned with ease. The gases gets cooled. Now, when the gases goes inside this corrugated tube here and there, it get cooled, and because it transfers heat to the water, water to form the steam. The next steam take the top flank through a bank of coil for superheating, and superheated steam is taken out as river. Here we see, I have explained just now, this is this bank of the coil itself, where it is the steam and steam is got superheated. Even the water, if present in the steam itself, it got superheated and converted into steam immediately. Since the pressure in the furnace is almost about the atmosphere, caution is required to make the case filled against leakage. All this, if, if the pressure inside the furnace is equal to more or less equal to atmosphere, generally the leakage doesn't take place much. But if the pressure is higher, it is producing more and more pressure over the walls. It should be properly sealed against any sort of leakage, because the leakage of any steam and even flue gas causes higher health hazard, as well as the total collapse of the total plant itself. If you don't seal it properly, the hot gas will filter, causing heavy energy losses and pollution to the atmosphere. If your seal is not okay, this hot gas comes out through the total boiler room, and as well as in the surroundings atmosphere, and it is extremely toxic for the human being there. But it has certain, this type of package type boiler. Package means is a total unit, total package. Everything is inside a particular volume of shell. All flue gases, coated reams, steam, uh, water reservoir, steam producer, everything, manhole, safety valves, all are inside a package, into a particular casing or package. But first, it has certain important advantages. It is highly compact, means everything is inside a single unit, and a large surface area is provided in a small volume, because you see the volume may not be very large, but so with so many tubes surrounding goes inside this water source, this will heat, and this will create a considerable amount of exposure of heat surface, where heat can be easily transferred on the flue gases to air itself, flue gases to the air itself. Now, a large uh, furnace volume is less, more or less it is pressurized. Since it is pressurized and no fast fan is required. Now, a short steel chimney is provided. A short chimney, it is provided here to, is just for disposal of flue gases itself. Here, through which all the flue gases are disposed. The entire unit is mostly fabricated in the factory itself. It is transported to the site installed there with relative ease. All these things, all individual parts like boilers, tubes, flue gas tubes, the superheated tubes, all these oil tanks, pumps, etc., everything are manufactured individually and brought to the project site itself, where it can be so easily assembled, and the functioning of this will start. But the paucity of the oil supply has reduced its demand, giving away the use of fluidized boilers, mostly based on coal. But everything is good except the fact of the supply of oil, because due to, as in our country, all these crude oils, all the petroleum-based oils, at as fast value is increasing day by day. So this running of this type of boilers is may not be economical in the large scale. Generally, it is used in small unit like in marine boilers, or sometimes even in the industry itself, meant for using hot steam, or sometimes the own power requirement of the industry itself, but not in a large scale. Instead of coal-fired boilers, these fire tube boilers are relatively inexpensive. Actually, they have large water storage capacity and can meet relatively large and sudden load demands only with small pressure changes. To reduction of pressures, what we see here, it is relatively inexpensive, not that expensive like nuclear power plant or so, but it is supposed to have a large water storage capacity, and due to which it can sustain relatively large and sudden rise in the load itself, and with a small pressure change, just reduction in pressure by opening every this exhaust valve, etc. The pressure is reduced and temperature thus increased, and so it is quickly superheated, and part of it flash into the steam itself. But huge water resources as a one problem, that it reduces the explosion hazard of the limit. So we have proper valve system, safety valve system, which will exhaust the additional pressure of the stream when if it is went beyond it. And also because of it, a large period of time is required to start and start from cold to hot position and from hot to cold position itself. The major shortcomings are at that definite size and pressure limitations are inherent in basic design. The maximum size of the unit and the maximum operating positions are limited. What is the problem here? It, although it can meet the load demands, increase in load demand, but it has a specific size and pressure limitation. So it cannot go beyond that, and maximum size of the unit and maximum operating pressure are limited by the strength of the drum itself. How the strength of the drum wall is a function of drum diameter and internal pressure given by sigma p into d divided by 2t. It is given here as the thin cylinders, treatment of thin cylinders in strength of material subject, where sigma is the tensile stress, p natural gauge pressure, d internal diameter, and t thickness. Sigma pi pd into t, this pressure of the drum in due to the internal pressure, what should be the thickness stress developed inside the drum, and what should be the possible safe thickness of the drum is required, can be obtained from this type of equation itself. But it has a specific limitation. It cannot go beyond that pressure on which it is designed properly. So we can have increased the load by only by reducing its pressure to a certain extent, so that the temperature of boiling point also reduces, and superheating of the vapor of the uh, I mean this water is goes up. But nowadays the growing needs for increased quantity of steam at higher and higher pressure, it could not be met by fire tube boilers as per the above equation, because both high pressure and large drum means larger wall thickness. Yes, high pressure and large diameter lead to provisionally thick cells, and then the thicker the cell, higher the cost. So the most important part in using is the higher, it is limited by the thickness of the air. The higher the pressure, higher will be the thickness, and you have to make the drums of with higher thickness stereo parts means it costs you more. So high pressure have the best probability thick cells, and the thicker the shell, higher will be the cost itself. Now this is up to this thing. It is the fire tube boilers are there. fire tube. Next, we'll go for water tube boilers itself. So let us go through quickly what we have gone through in fire tube boilers. First is application. It is limited application railway and river launches or ongoing ocean liners itself. Industry, they are really not used, and sometimes used in for to make create a saturated water stream at upper limit of say 18 to bars and 6 kg per second capacity. They have used for limited requirements. Yes, they have inherent advantage. Fast cost is comparatively less, and it is reliable in operation. Required unskilled operator because you don't operators don't have to do much except to control the main stop valves, to see the name, to see the pressure readings from the stop valve and see whether the pressure goes up, the stop valve is properly functioning, it's releasing the pressure also. If it's not functioning properly, what is the remedies they have to know. So don't require a high skilled operation, and uh, which have and less amount of draft means quick response to low disadvantage. Less amount of draft means this chimneys or draft is not very high. It is not required to be very high because very small amount of only except for the fumes, only small amount of dust or ashes are coming out through this chimney. So it is not required to make it high so that it can distribute it to the atmosphere is much higher. Here, the basic difference is that product of combustion is passing through the flues or tubes and surrounded by the water. This product of combustion is or heated gases or tubes may be formed by heating the burning the coal and sending the flue gases through the tubes, or by burning the oil and sending the flue gases through the oil through the tube itself. Tubes are all surrounded by the water, surrounded by the water, and this temperature of the heat generated inside the tube itself is being transferred to the water. So the tube got cold and water got heat up and created more than 100 degrees centigrade temperature for specific pressure, is creating steam, and it also has certain benefits of uh, rewinding the outlet of the pressure, outlet of the steam itself, because outlet of the steam itself because it can superheat the boiler as per our requirement itself. There should be a safety valve always. It is spring operated and spring pressure is to be sufficient and not more or less, which is required for releasing the high pressure stream, which is beyond the capacity of the boiler drum itself. There should be holes should be formed and to put out the fire. Holes should be formed somewhere to for the entry of the operator and cleaning and rectification of any defects. There are two types. One is coal fired and oil fired. Just a minute, I have explained the oil fired furnace. Here, the advantages is that this is much less polluting um, than the coal itself. It creates much less amount of fumes and much almost no ashes at all in comparison to the coal itself. But problem is, in comparison to coal, it is much costlier. And another advantage is there. Oil can be moved from one place, from the source to the point of use rather easily than the coal itself. Only few drums, few tankers is enough for run the oil per day. But when you locomotives full of coils is required every day to be moved for running each and every power plant itself. Now, the but the oil main disadvantage of oil fired tube is in comparison to the coal fired internal tube furnace is that oil is much expensive in our countries, and sometimes it becomes the capacity of your economic use because you cannot increase your value of your power to after a certain degree, and thus this type of oil fired furnace is mostly used as a stopgap furnace where there is a high load, certain high load to make it for running a few hours and then close it, stop it again when the demand is made. So directly the use of oil fired furnace and is taken over that the coal fired furnace is set. Now, let us go water tube boilers. Sure. Now, let us go the let us go into the go through the water tube boilers itself. Now, this type of boiler is developed to permit increase in boiler pressure and capacity with reasonable metal stresses. So, the main disadvantage of the um, fire tube boilers is that it cannot permit much higher pressures because its drum is being designed to sustain up to a certain pressure, limited pressure of limited internal pressure. But here, this process has permission to increase the boiler pressure required, and the capacity of requirement is can be increased with immediate reasonable metal stresses, with the stresses which is more or less reasonable, which is within your affordable limit. Due to the higher steam pressures and capacity, fire tube boilers would need higher diameter shells. Here, fire tube boilers generally require higher diameter shells, and with such large diameters, shells uh, would have to operate under extreme pressure and temperature stresses. That thickness would becomes very large. They also suffer subjected to high scale deposit, subject to high scale deposit, huge scale deposit, and in susceptible to water boiler explosion and becomes very costly. So here to make the drum of the water fire tube boilers comes there is make the drum you need to spend much higher amount of money. And what is that? Because fire tube boilers requires high diameter shell. High diameter means the surge is less is more, and both with large diameter shells should have to operate under extreme pressure and temperature stresses. That thickness could alone becomes very large itself. So extreme high temperature and thermal stresses and high temperature pressures, thickness of the boiler is to be very high. That's higher the thickness, higher the sub purpose of higher is the cost of manufacturing the same. Now, the water tube boilers, where the water flows through a tube and flue gases flow outside them, put the pressure in the tube in relatively small diameter drums, which are capable of withstanding extreme high temperature pressures of modern steam temperature. The basic difference in the water tube and fire tube boilers is that in fire tube boilers, flue gases flows inside the tubes and water are surrounding the tube and got the heat from the flue for its vaporization. And but for water tube boilers, waters go through the tubes and the fumes are surrounding it and applying the heat to the flowing water, and thus making the steam itself. So large amount of uh, small diameter large size of the drum is not necessary, and small diameter drum is required. It's also not withstanding much pressure, so extending maximum pressure it can exert, because it is not expanding much pressure of it in terms of like the fire tube boiler itself. Now, the single tube boiler, there are different varieties: single tube boiler, bent tube boilers, like this. The water tube boilers went through several stages of development. The earliest design employed straight tube boilers with heaters at each end, because straight tube could be made, installed, and replaced easily. but tubes are around 75 to 100 millimeter diameter and diameter OD and inclined upward at about 15 degrees centigrade to the horizontal and staggered line. Nearly saturated water leaving the drum flowed through one heater called the downcomer. Naturally, saturated water leaving the drum flows through one heater called the downcomer into the tube. While flowing upwards in the tubes, some of this water is being heated by flue gases flowing inside and get transported into vapor in the two-phase water steam mixture went back to the drum through the other header. What is this? Here, the saturated water leaving the drum flows through one header. Header is called a collector. Header is nothing but a collector. Header is nothing but a collector of the drum itself. Now, it is called the downcomer. Means this while flowing upward in the tubes, some of the water being heated by flue gases going outside, get transported to vapor, and two-phase water steam went back to the drum through other headers called riser. So there are two headers. One is defined as downcomer, another is defined as riser. The one heater called the downcomer, it is flowing while flowing upward. Some of the waters are being heated by flue gases outside the flowing outside get transferred into vapor into two-phase water drip mixture went back to the drum through the outer heater called a riser. Let us go through the picture itself. This is the diagram of the water tube boiler itself. Here you see this is the tubes through which the water is being carried and over which the fumes are surrounded by it. It has one header here is called downcomer and this is another header here which is called riser itself. The water uh, heated heated water flowing through the drum is goes to the one of the downcomers and then means downcomer then is very specific. It is come down and again goes through it, and after the proper temperature and pressure is reached, it goes to the riser and go from the riser it goes to the drum itself and being collected from the outlet here. The food the and the density difference is called natural circulation difference. As both these heaters are not running in a different temperature, so the water and steam mixture itself is a different pressure inside, and thus there is a density difference, and it causes higher densities will move and lower densities will move up, higher densities will go down, and like this. Drum was used either parallel to the tubes, original longitudinal drums, or perpendicular to the cross drum. Here it is longitudinal drums. It is placed parallel to the tube itself, and the feed water from the feed water heater flows through an economizer itself, which is nothing but the heater or reheater of the steam or water itself. And the drum was arranged either parallel to the and longitudinal. The feed water from the feed water heater goes to a consumer which supplies saturated steam to the superheater itself. Lower end of the downcomer was connected to a mud drum where collected sediment upon the circulating water discharge. So here is a mud drum here, somewhere here with sorry circulated it is the circulating water and discharge through the blowdown itself. A single longitudinal drum about 1.2 meter diameter can accommodate only a limited number of tubes, and the tubes and hence a limiting heating surface. Depending on the capacity itself, more than one drum could be installed in parallel. Longitudinal drum boilers are limited to low pressure, borrowed 12 to 23 bars, and steam capacity 0.63 to 10 kg per second, having heating surface having heating surface 93 to 930 millimeter square at minute. Hello, kilo. The things are like this itself. The cross drums, a single longitudinal drums about 1.2 meter in diameter, can accommodate only a limited number of tubes. Hence, a limiting heating surface depending on the capacity. More than one drum could be installed in parallel. Longitudinal drum boilers are limited to low pressure and steam capacity, having heating surface equal to 93 to 930 millimeter square. So, a single longitudinal drum can accommodate a limited number of tubes. So, limiting the heating surface depends on the capacity. More than one drum can be used. More than one drum can be used, and more number of tubes can be used. Both are acting installed in parallel, means capacity both are supplied with oil and slaughter supplied with food gases, and the temperature can be then the pressure generated vapor thus generated can be comes out from a single outlet itself. Thus, longitudinal travelers are limited to low pressure 23 millimeter boiler and steam capacity around 60.3 to 10 kg per second heating capacity. Cross drum boilers could accommodate more tubes than longitudinal drum boilers because of their geometry and were built with heating surface and pressure tubes. Longitudinal means this type of tubes are along the length of the jump along the length along the longitudinal length of the furnace itself, where flue gases are going through it and is being surrounded by the water itself. But it can be one or it can be multiple, depends on the requirement or capacity itself. The cross drum boilers could accommodate many more tubes in longitudinal drum boilers because of their geometry. Because across the thing, it can more or less cause, it is longitudinal like this, or if it's across the length, it is supposed to be uh, more number of tubes, and more if there is more number of tubes, more amount of number of heating surface with 93.23 millimeter square, pressure equal to 12 to 100 bar, and steam appears capacities of 0.60 to 60 kg per second. So to start with, first we have gone through what is the water tube boiler. Water tube means water tube boiler means flue gases flow inside the tubes, and for fire tube boilers, flue gases flows through the inside the tube, and uh, the waters are surrounding the tube. Now here, water goes through the tubes and flue gases surrounding it. Both are this way. The heat from the heat flue gases will transfer to the water, causing water tube formation of steam itself. For here, as the flue gases are flowing inside the tube, we had two items like right downcomers and heaters, which are used as the header means the collector of all the bunch of tubes will be fixed on one side to a chamber, which initially collect all the fluids which goes through the tube, and then it sends through all the tube more or less at the same capacity itself. and uh, both are at the downcomer. First, from the drum, water comes out and goes to the tube itself, and from the riser it goes up and goes out to the superheated tube work, and it moves out of the vent itself. Thus, there are longitudinal drums are there, and there is also cross drums are there. So it is both of them can accommodate and should accommodate very more tubes, and both have their limitations and advantages. Parallel drums have low pressure and low pressure and low steam capacity, and heating